Okay, the string format method, it's got a lot in this 816 here. So we'll take it a little bit at a time and look at what each thing is doing. So I have a string here and we use format, and we'll see how this works here. Let me go here to, oh, I need to insert a cell down here. So if we start with this, I've made a string, and his name is, and then it's got this curly brace, 0 curly brace, and exclamation point dot format. So here's the dot format is the method, and it takes an argument, but it can take as many as you want to give it. But it's like a list. So this first argument has index 0, so that's what this is saying. And if we run that, so you see it's substituted Arthur for this wildcard here of index of 0. And the reason it would do that is because you know, what you might do actually is say that S1 is that with the wildcard 0 in there, and then you could say, for instance, print S1, oops, S1 dot format Arthur, like that. But then you could also print you know, something like let's say instead of Arthur it's Art, and so, you know, a nickname there. And so you see this S1 will take that any format, but it's got that wildcard placed in there, that index in there that will take anything from here. And so we run that, and you see his name is Arthur, his name is Art. So it can do both of those. Then here we're seeing where it takes 2 wildcard arguments, and I call them wildcards because we can make them whatever we want. And so I'll put that in the same space here. And so now it's going to do age here because age is index 0, and name here because name is index 1. But you see we've assigned name Alice and assigned the age 10. So the 10 is actually an int or an integer, but it will do the formatting to a string as part of this. So again, if we run that, so we see I am Alice and I am 10 years old. Okay, and then here they've got a whole bunch of things. Let's look at them. So here they said N1 is 4, N2 is 5, and what they're going to, they say 2 to the 10th is equal to the 0, but they actually do the math here. So there's 2 to the 10th, and then they say 4 times 5, so here's actually, yeah, here's N1, so that's 4, N2 is 5, and then they do the math of N1 times N2, and here they put the F after it, which says format it as a floating point number. And so if we run that, so we see the 1024 that came from the 2 to the 10th, and there's a 4 times 5 equals, and then they did that as a floating point number. Okay, so that's that first set of things they have going there. Now, and they say, okay, you run that and you get that 20.000, but we can do more with this. So actually, I'm sort of disappointed they don't get into this right away. You know, why would I write 4 times 5 is 20.00, you know, all those zeros? Well, what we can do is down here, you see we can give that index a particular format. In this case, it's saying use 3 decimal places. So let's go back to this one and do that. So this was 3, and I don't remember, I probably copied way too much. Yeah, I copied not way too much. So here's, you know, it says 0.3. Well, what's that change? And now you see I only have 3 decimal places. If I put 0, you see it rounded it, well, it didn't really round in this case, it truncated it to 20. And so you see we can do the how many decimal places there we want. Now, and I'm not sure if, let's say I put a 3 on the front of that. I don't know if that's an error, or because in some things that works and some it doesn't. So here it put a, it's hard to see, but it put a blank space in front of the 2. Now what's other ones, they tend to work the same way, is it says that 3 here, the 3.0 is saying I get 3 spaces, I believe. So for instance, if I did 3.3, let's see what happens. You see it took more than 3 spaces, so it didn't give me that extra space at the beginning. You know, but if I, you know, so this takes a total of 6 spaces to get this. So if I change this to like a 10, we'll see a lot of space in front of there. So I've made the field width of this whole number 10, but I only want 3 decimal places on it. Or, you know, I made it 10 and I only want 0 decimal places on it. And I can do that. That's very ugly, but I can do it. So better would certainly be this, where I just use what space I need and don't do the decimal places. Okay, so that's our first introduction to that with the number of decimal places. So now let's go back and copy their stuff here. So they've got a bunch of things. So they've got names here. Paris Whitney Hilton. I don't know if she's still somebody you all consider famous or not. She's basically just famous for being famous. Okay, so there we put all that. I'm gonna clean this up a little bit. And this one. Okay, so here, okay, so pi to 3 decimal places. So they're going to do 3.141. Now it's 5/9. So you get to see right here, does it round or truncate? If it rounds, we'll get a 3.142. If it truncates, we'll get a 3.141. And here they're just printing out digits to kind of keep place. So this is you know, nine places and then a blank spot for the 10th. And so when I get to this blank spot, now I've done 20, 30, 40. So this is just kind of keeping up column numbers. And then they're showing us this thing, so it prints these 3 vertical lines, and then it does the 0, so that'd be the N1. Now this less than sign is not possibly what you think it is. It's saying left justify this thing. So we should see Paris left justified in the first 15 spaces. And then this caret here for the N2, the argument 1 here, that's saying center it in the next 15 spaces. So that gets us to 30 spaces up to here. And then this N3, Hilton, it's going to right justify it. That's why the arrow is pointing that way. So those are all justifications, but it puts those 3 lines in there each time. And then born in 1981, it'll put that in. Here they're showing that you can actually give a format, so up here it was F for format of floating point. Here the X is to get hexadecimal, so I could convert very easily to hexadecimal that way. So let's run these. And so you see it does round, it's 3.142. And then here as we look at these spaces, so we went 3 spaces, and then Paris got 15 spaces, and so we're up to 18 up here, 18 spaces. And then we did 3 spaces, 3 of the vertical lines, and then we did 15 more spaces. So we were at 21 plus 15 is 36, or sorry, 36. And so that got us to 36 spaces, but you see Whitney is in the middle of all that, and then Hilton is right justified in those 15 spaces. And then finally the born in 1981, that didn't come with any particular number of spaces, and so there's no need to justify or anything like that, and it put that in there. And then it took 1, 2, 3, 4, 5, 6 and converted it to hexadecimal, which is 1E240. Now that's something that I chose not to do with this course, was going to binary, octal, hexadecimal representation. That's all good stuff. You're encouraged to learn more about it. We just didn't put it in this course. Okay, so we're seeing other things we can do. We can left justify, right justify. We can, just as I did back here with the when I originally did it with the 3 or the 10.0, we can come up with the number of spaces we want to use to put in our argument here, and we can also decide whether it's left, center, or right justified. We can do nifty things like switch to hexadecimal. I don't know if, like binary, what happens if we do a B? I haven't looked that up, so I don't know. Oh, there it is, binary. So it did it as binary, hexadecimal. If you do an O, it might do octal. And it does. So it'll do octal. So base 8. So, base 16, base 8, base 2, it will do all of those things. All right. So there's the output that we were looking for. And now here's a letter. And so we'll toss that in. Okay, so there we're going to print out letter, and notice here they're using the 2 different format statements for the same text here, same string, and they do, notice they don't use the middle name at all. They do the first name and the last name, and then they use the first name again here. And so if we run that, So we have our Dear Paris Hilton, Paris, and Dear Bill Gates. I'm not sure why they're trying to teach us how to scam money, but I guess that's up to the book. But so again, that's how you can use that format statement to do some very efficient filling of form letters and various things like that. Now, and this just points out that here I only had one item, so I should have used an index of 0. They use an index of 3 and they get an error. Now here's an interesting thing here. So they're showing us you can put a tab into this stuff. So I'll make a new cell down here. So they say print I, and then they use this \T. So that's a tab. And they say in the text it's every 8 characters. So it's as if what I did was on all these, I gave it a field width of 8. And it left justifies these things. So if I, so it's going to show me that, but then it's going to show me how using the tab statement can get ugly. It looks good at first. So you see there, it looked pretty good. These are all working nicely, these first 3 lines where it does powers, integer powers of the integer there. So 1 squared, 1 cubed, 1 to the 5th, 1 to the 10th, 1 to the 20th. So this all hangs together okay until we get too wide. And then the problem is, see, this one's still doing fine, but this one gets shoved over farther because this is too big for the tab to fit everything in. So 2, 4, 6, 7. So actually, I would have thought it would have started this one here at 8 from what they say in the text, but at any rate, it gets ugly, and they're saying, okay, so that looks bad, okay. But if we compare that to doing this, where they've set the layout with the indices to make it look a little better, then we can get a much nicer looking output. So here you see what they've done is they've said the first index, 0, we want 4 spaces for that, and we want to right justify it. So all of these are right justified, but they go up in the number of spaces that they allow for each one. So 4, then 6, then 6, then 8, then 13, then 24. And when we run that, so then here it says, well, print layout format here. And then again, they use that same layout, but then format with lots of different stuff, but it looks so much better down here in that, everything lines up, it's right justified, so I can see them very easily, and so it all looks good. So that is a way we can do that. And that was the end of this. I could give it, you could experiment with something like this. So for instance, we could have made, we could have thought, well, let's try 6 and 8 and 10, and then we do the 13 and 24. But let's say we thought, okay, that could be 12. And that could be 14. Say we just thought that we could get that, and we run those. And you see, we see very quick, we had too much, we didn't need that much space back here, but that's a problem. right? That looked really bad. We didn't give it enough space. So, you can either, kind of do trial and error to figure out just how big you need those to be. Um, like, does 23 do it? They use 24. What does 23 look like when you do that? And actually 23 made it with a couple spaces. There's one space in there, so that one could be a 12. Now I see a couple extra spaces, so actually it looks like this could, technically that could go down to 22 and I could still see them. This other, maybe it could go to an 8. We'll see. This column, we could go to a 5, I think. This column is 3-digit number, so we could definitely go to a 4 there. And we've got a 2-digit number, so we could go to a 3 here. And yeah, actually, what is this? This is 10 to the 20th. So I know that's 1 followed by 20 zeros, so I really only needed 21 spaces if I wanted to use the very least possible. And here, 10 to the 10th is 1 followed by 10 zeros, and so that's 11 numbers, so I needed the 12. And let's see, this is 10 to the 5th actually, so I guess I really only need 10 to the 5th, that'd be 1, so I only need a 7 here. And then cubed, I'll need 5 spaces. Squared, I'll need the 4 spaces and 3 spaces for that. So let's look at that. So that kind of puts them in as small a spot as possible, but still shows me the separation. That's probably not as nice as putting more space in there, but I just want to show that it's up to me how much space I put in there. And so there we have it. There's a bunch on formatting.